Okay, today we're going to go over transistors. What I need you to do is have a pencil and a piece of paper out to take a couple notes. Our learning target today is I can create a circuit that uses a transistor as a switch, and you will know you've successfully completed this target if we are able to turn off a component like a motor, LED, siren with a transistor, just like a switch would. As this video goes along, you'll have to pause it from time to time to go ahead and get down the symbols and notes, so make sure you're ready to do that. What are we going to see in this lesson today? Well, we're going to see what a transistor is. We're going to see the parts of one. We're going to see what the first one looked like. We're going to see how they can be used as amplifiers, how they can be used as switches, and then we're going to see the nightlight circuit that we will be creating as well. So what is it? A transistor is a small electronic device used in a circuit as an amplifier or a switch. So it can either amplify the electricity and make it greater, or it can be used as a switch to turn it on and off. Here's the symbol right down here. It's a little more complex than we've seen before, but not too bad. You can forget about this NPN transistor, just ignore that for now. And over here it shows you if you were to break open an electronic device and see all the different parts, these are what the transistors look like inside. Go ahead and pause this video and take down the definition as well as the symbol for transistor now. So what did the first one look like? Well, right here in this picture. Big, bulky, definitely not something you'd have in your cell phone today. It was considered, however, by some to be the greatest invention of the 20th century. It was invented by Bell Laboratories in 1947. It's a crucial component in almost all modern electronic devices. Of the things on this page, this is the one I want you to write down. Okay? It is in almost all modern electronic devices. We would not actually be able to have a lot of the things that we use every day without this. The computer screen in front of you wouldn't have it. The actual computer to the left of that computer screen, we would not have that either. Our cell phone in our pocket would not exist. The TV that we like to watch when we go home wouldn't exist. The video game console that you like to use would not exist. A lot of these modern electronic devices really depend on transistors to function. Engineers are working towards making them smaller so that more can be placed on a computer chip. Many today are already smaller than a human hair. So that's the second time that we've heard that. And if you haven't noticed a trend, electronics are trying to get smaller and smaller and smaller because that's just the way that demand is. Okay, we're trying to build smaller and smaller devices to do more complex tasks. So we've heard about motors becoming smaller and smaller. Now we're hearing these things are becoming smaller as well. Okay, so the only thing we need from this page is this third bullet point. If you still need to write it, go ahead and pause now. Parts of the transistor, we are going to skip right over this one. We'll talk about those over here. So ignore this stuff right over here, the NPN and PNP. We're not even going to look at that. What I really want you to do is take a look at this right here and actually draw exactly what you see that my mouse is hovering over right now. This black symbol with the collector, base, and emitter. This is really important because it shows the three parts of the transistor. So go ahead and draw this basic shape here and make sure and label each one of these strands that are coming off of it. One's called the collector, one's called the base, and one's called the emitter. And basically what this is representing is, if you look over here to this picture, it's representing the three pins you see here coming off the transistor. We also want to write that the small base current controls the larger collector current. Okay? We want to write that down after we've gotten this symbol written. Doesn't make sense to us now. We will see that in future slides. Okay, so just go ahead and pause, get that written down now. Okay, here's how it works. I like to think of it as a drawbridge. Okay? When a drawbridge is up, cars cannot pass over the bridge to get to the other side. That is exactly how a transistor works. When there is no current flowing to this base wire, or this base strand here, No current can flow between the collector and emitter. Okay? The transistor is basically turned off. So if this wire is not getting any electricity, the switch is basically open so that no electricity can go through it. And hopefully you can see here in this example how, yeah, if you think about this as a bridge, there's no way for electricity to get across this way. Okay? So basically, in order to get this thing to drop down and have electricity flow through here, we need to have a little bit of current going through this base. Okay? To show that, if you put a small little amount of current through here, it's going to drop that drawbridge down and allow this collector to feed a whole bunch of electricity through to the other side. Okay, so kind of a complex component. Okay, so a small current to the base enables the transistor to conduct current from the collector to the emitter and allows a larger flow through a larger current to flow through the transistor. Okay, components connected to the collector can use this larger current. So once again, like I said, it's kind of tough to think about, but you need just a teeny tiny bit of electricity to go up this way and hit this base. And once it does, it drops down, and then you can have a ton of electricity sitting here waiting, and that'll flow through, it'll rush through, okay, to whatever component you need to power up. All right, so that's how a transistor works. It's very complex compared to some of the other things that we've learned. But if you think about it like that drawbridge, hopefully that makes sense to you. Okay, so once again, it's just showing us how the small base current controls a larger current. Okay, so the collector has a bunch of electricity coming up here, a big current. It wants to pass, but it can't. Okay, because right now we have nothing coming up the base. But once we put a tiny bit of electricity up that base and it hits, the drawbridge drops. Okay, and then all of a sudden electricity now can flow through the transistor. So hopefully that's starting to make a good visual for you and you can see what's going on here. Okay. You don't need to write any of this down. How it's used as an amplifier, basically what I describe here is you can think about it like a microphone. How does that work? Okay, because a lot of people say, I just don't get it. It's still kind of foggy for me. Well, a transistor can be used as an amplifier. And if you think about it like a microphone, you need to put a very small electrical impulse through this microphone and feed it to a speaker, which has a ton of electricity waiting to go through it. And as soon as your voice signal travels from that microphone and hits the transistor, okay, that's like the bass symbol right there. Your voice going through that line or through the microphone, it hits the bass, and then that speaker's current, the big amount to make your voice really loud, flows through this transistor as soon as that bass makes the drawbridge drop. Okay, so this is our small little bass current, and over here is our big current, the one that's running through our speaker. Okay. Now, we're going to use a transistor as a switch. We're not going to use it as an amplifier because it gets a little bit above what our snap circuit kits can do. However, we can definitely use it in a couple different ways with our kits. What I would like you to do is go ahead and draw this circuit right here. And if you're feeling up for a challenge, I want you to go ahead and try to draw it now. Before I show the answer. I think it would be helpful to draw it, check your answer, and if you need to, go ahead and change it at the end. So if you're up for the challenge, go ahead and pause it and try to draw it now. Okay, and go ahead and check your answer. All right, now very important here. This is all one big symbol, or one big circuit. Make sure that this you have written down as a battery. For some reason in this lesson, they switched the battery symbol to look like this. we can use our normal battery symbol. You do not need to use this one. And the other thing, to make it easier for when you go into the lab, you can actually extend this wire and drop it down right here. I'm not sure why they moved it all the way over here, but you can see in the actual circuit, you do want that wire to come all the way out and be parallel with this one out here. So you can extend that one out as well. Just makes it a little bit easier to see. So we have here our battery. And the first strand here, we have a 1 kilo ohm resistor and an LED, and that goes to the collector of the transistor. And then down here we're going to have a push button switch, a 5.1K ohm resistor to make a really small current, an LED here, and that goes to the base of the transistor. And then the emitter just comes around and goes back to the negative side of the battery. Okay, so that's what we have going on in our transistor circuit. What we're going to realize is that this, until you push this push button down and you get a current going to the base to drop that drawbridge, this light will not turn on. Okay, LED circuit. Okay, we're going to kind of skip around here. What we're going to do is we're going to create an LED circuit, and let me see if there's a good, there we go, there's a good drawing of the circuit. What I want you to do is write this one down, so go ahead and pause your video and draw this circuit. This is the second one we will make, so I'll give you a chance now. Okay, hopefully that's drawn. And now I'll explain to you what's going on here. Once again, you can use your normal battery symbol. You do not need to use this circle with the plus and minus. What we have here is one path that's going up and around with a 1K ohm resistor and an LED, and that goes to the collector. And that will not turn on until we drop the drawbridge or turn on the transistor. Well, what we have for the second path is a 10K ohm resistor. Okay, and what it's going to do, or the electricity is going to do, is it's going to go through this resistor, and that's going to go through this thing. And if you can remember what this thing is, you get bonus points. This is a photoresistor. So it's going to go through both of these things and back to the battery, so long as this thing sees light. Okay? So long as this thing sees light, the electricity is just going to go through this path. It has no problem just being fed through here over and over and over. It doesn't care that it can't get through this way. However, if we put a bit more resistance into this path, okay, so let's say make this dark so the resistance goes up, now the electricity is going to say, let's try to maybe go down this other path because it seems a bit easier. So it's going to push its way up to the base of the transistor. And remember, as soon as electricity hits that base, the drawbridge drops. Well, when the drawbridge drops, then electricity can go through this way. Okay? And your night light, this LED, will turn on. Okay? So if this sees dark and the resistance goes up, the transistor will work. Okay? But if it sees light, it's just going to let the electricity keep going through this path over and over and over. Okay? Pretty complex, but that is exactly how our nightlight circuit will work. So go ahead and make sure you have this drawn down. And once you are done with this video, we can go into the lab and make the first transistor circuit that we saw in the video, and then the second one, which is the nightlight circuit. Go ahead and get started now.